example problem, we are given a rod that has 4 forces being applied to it, and we're asked to determine the total moment about point O here. All right. So we have 4 forces: force 1, which is the 50 Newton force; force 2, which is the 60 Newton force; force 3 is the 20 Newton force; and force 4 is the 40 Newton force here. Right? So to determine our resultant moment about point O, we're going to find that's the sum of all of the individual moments. So it'll be due to the moment due to force 1 plus the moment due to force 2 plus the moment due to force 3 plus the moment due to force 4. Right? So we're going to solve for each of the individual moments. Right? So the first one we're going to solve for is moment due to force 1. So that's going to be equal to force 1 times d1 times the sine of the force and the distance and d1 theta. All right. So we were given force 1 was equal to 50 newtons. All right. D1 is equal to 2 meters, and then the moment arm D1 and F1 are 90 degrees apart. So you would say this would be equal to sine 90 degrees. All right, and then the last thing we need to include here is a negative sign. And the reason we have to include a negative sign is that if you look at our D1 and F1 here, all right, is that if you looked at the if you use the right hand rule here and you pointed your palm along D1 and you applied your fingers along F1, your thumb would point into the screen. All right, and that means that it would cause a clockwise moment about the system, and which would cause it to rotate clockwise, which we define as being a negative moment. All right, so all that being said, we'll end up getting a sine of 90 degrees is 1, and 50 times 2 is 100, so we'll get minus 100 Newton meters for moment 1. Okay. So our second moment is going to be M2. So M2 is going to be equal to force 2 D2 times the sine of theta. In this case, force 2 is 60 newtons. D2 is 4 meters. So it's the distance from point O to where force 2 is being applied. And then the sine of theta, in this case, theta is 0. So sine of 0 is 0 degrees, so we get 0 Newton meters for M2. All right. So then we can go down to the third moment arm, M3. So we can write this as force 3 times d3 sine of theta. All right. So in this case, force 3 is applied at the very end of the bar. So we can determine d3 sine theta would be equivalent to the distance from our origin point to the y component, or the y, a line that's drawn parallel to the x-axis at the point where force 3 is applied. So this would be our d3 sine of theta would be that distance. Okay, so we can calculate that very easily. That would be equal to 20 newtons times 3 meters times the sine of 30 degrees. All right, so 20 meters times 3 times the sine of 30 degrees. Sine of 30 degrees is just a half, so we end up with 30 Newton meters. Okay, and based off of our our D3 and our F3 moment arms, that's going to create a counterclockwise moment about our point O. Therefore, it should be a positive moment. So it will remain as 30 Newton meters, not negative 30 meters. All right, and then the last one we would get is M4. All right, so you should get, this would be equal to F4 times D, D4 sine theta. All right, in this case, that's going to be equal to 40 newtons times 4 meters, which is the distance from where point O is to where force 2 is being applied, plus 3 meters times cosine of 30 degrees. All right, if we multiply that all out, and I guess the other thing we should mention here is that it looks something like this. D4 sine of theta would be going along the x-axis, and then we would get F4 would be going down. This would create a clockwise moment if we use the right hand rule, and therefore it's going to be a negative moment. So we're going to add a negative sign here. If we multiply all this through, what we end up here is going to get minus 263.923 Newton meters. All right, so let's add up all of our values here. So we get our resultant values. We're going to get, it's going to be equal to minus 100 Newton meters plus 0 Newton meters plus 30 Newton meters minus 263.923 Newton meters, which is going to be equal to minus 333.923 Newton meters, or if we round, it'll be equal to minus 334 Newton meters. So that means that we have overall we have a clockwise moment that's being applied to our bar, and it's equal to 334 Newton meters. Right. So just to summarize what we did, we first identified all the forces being applied to the system, and we determined that the total moment would be equal to the sum of all the individual moments. We then calculated all the individual moments using the force times the distance times the sine of the angle between the force and the moment arm. We did it for all 4 values, and then we just algebraically summed up all the numbers to get the total resultant force.